we have ample time. So from the next week also, I will start at 11:30. It will be better for me because in the first class, I have to shout a lot. And believe me, this is, I did not do it for you, but probably it was needed for your case as well. I'm sorry for that. But in this year, it is clearly mentioned in the academic, what do you say, calendar, that I means everyone, all the teachers should repeat whatever they have taught before the spot admission. So what happened for me is I finished 2 chapters. You know that I go slow. I finished only 2 chapters. In some of the cases, almost whole of the syllabus was finished. But for my case, 2 chapters I finished, and I have to repeat the whole thing once more. So anyway, so that's a little bit of additional task. That doesn't make any big difference in the teaching pattern, but anyway, I have to repeat the things, and maybe I'm shouting a little bit more like the original class. In the duplicate class, I'm shouting a little bit more. Anyway, I'll start from the next week. I'll start from 11:30 because we have enough time. Okay, let me come to the point. I was talking about 2 different type of properties: configurational properties and mechanical properties. If I give some example. Mechanical properties means hardness of a material, toughness of a material, strength of a material, etc., etc. Configurational property means, area moment of inertia, mass moment of inertia, etc. In some cases, apart from area moment of inertia, mass moment of inertia, particularly in case of spring, some other things will also come into picture. But these are the basic things which we'll be dealing with. This particular laboratory, if I focus on the material properties, or more correctly, the mechanical properties, we have some scopes, some objectives. What are the scopes? The scopes are, we can try, because you have already finished your coursework on strength of material, at least the first coursework on strength of material, and already one coursework on material science. We should try to correlate the materials behavior, or I should say the mechanical behavior, not the materials behavior, mechanical behavior with the material structure. That sort of a scope we should enjoy. We should try to focus on how the one type of material structure is giving rise to one typical type of properties, set of properties. That is one issue. Second thing, if I focus on the mechanical properties itself, we should try to make, or we should try to underline few things which are the minimum take-home messages from the laboratory. Laboratory class, you are supposed to do something in the lab. If you do not come to the lab, you are not in a position to come to the lab, then definitely it is not very easy to deliver whatever is expected from a laboratory class. But what we can do is, we can go for some discussion. We can try to share few videos with you. We can try to go for some elaborate discussion, and also giving you some clues so that you yourself can read out from different sources. I will share the sources, or at least I'll tell you what are the sources. So this is more like not exactly a practical course, more like a theory practice combined. So in that sense, I am starting this discussion that what are the basic take-home messages, basic take-home lessons from this particular coursework. It's basically you are supposed to know about, basically, not overall, basically you are supposed to know about the mechanical behavior of materials. Different type of materials. What type of materials? Around us, we see different type of materials. If we classify them, then we can classify them as solid, liquid, gas, etc. No, I'm not entering into those details. You know what is meant by a solid. You can hold it in hand. You can hold it in hand. It has the dimensions, etc. And in materials, and from material science perspective, there is long range order inside a solid. What is meant by long range order? That means if we think about, suppose I'm placing myself inside a piece of say iron, piece of iron, inside a piece of iron, and I'm starting my journey from that particular point, moving in different directions. I will find, as you know, the concept of unit cell, etc., you have gone through in material science, that there is a repeatability of atoms. In different direction, there is a definite pattern in which atoms are arranged. After a certain distance, Miller indices and other factors. I am not entering into the details of those things because that is basically in the domain of material science, but I must touch upon. If I want to start my journey from that particular point in different directions, I will come across atoms at a regular interval. Very good. And not only that, if I keep on moving in a particular direction or different directions, the regularity is not haphazard in nature. Haphazard in nature. There is a specific order. In one direction, suppose after 1 angstrom, I am getting one atom. Next, another. Next, another one. Another one. Another one. After 1 angstrom. Okay, sorry. Just a minute. A class for PG class, please. সৌরদীপ, আজকের ক্লাসটা হয়তো হবে না, আমি তোমার সাথে একটু পরে কথা বলছি, এটা ক্লাসের মধ্যে আছি। ঠিক আছে। Okay, now repeatability in that sense. In another direction, I may not find that every 1 angstrom I am getting an atom. No, maybe 1.2 angstrom I am getting an atom. But that doesn't mean that in that particular direction, one atom is at 1.2, the next one 1.5, next one 1.7. No, not like that. Regular. In definite directions, we have a regular repeatability of atoms. We call it ordered state. Now, this particular ordered state or this long-range ordered state is present in solids, more correctly in crystalline solids. Crystalline solids, all the solids around us, they are not crystalline. You have learned in case of material science. I am repeating it once more. In case of glass, that particular thing is not there. Though glass is a solid object, this long-range order is not there. That's why we call it supercooled liquid. But in different types of metals and alloys, it's there. In polymers, it's there, but not exactly in the true sense. The type of thing I have just discussed, repeatability of atoms, that type of repeatability of atoms may not be there, but repeatability of some other entity will be there in case of long chain polymers. I'm not entering into those domains. Yes, time will come, we'll discuss. But the repeatability or long range order is an important issue as far as solid object is concerned. Generally speaking, there are some special cases like glass, forget about that. Second thing is short range order. In case of fluids, more correctly, liquids, we have short range order. In case of gas, we have no order at all, totally chaotic. The atoms are moving in this and that and this direction. You know that Brownian motion, etc. You know. As far as entropy is concerned, have you gone through the coursework of thermodynamics? I think yes. Thermodynamics?
Yes, sir. Second, sir.
Yeah. In case of thermodynamics, you have come across a term known as entropy. And you know, even before you, some of you were knowing that entropy means the extent of disorder. So we can say that higher the order, lower is the entropy. So in case of solid object, lower is the entropy, lowest entropy. In case of gas, highest entropy, highest disorder. So disorder is the measure of entropy. Okay, that much we can say. And this is a sort of connectivity between material science and also the thermodynamics. At some point of time, maybe we'll refer to that the calculation in case of material science, I do not know whether you have done any calculation or not, activation energy, this and that, this requires a lot of knowledge of thermodynamics. That's a different issue. I am not entering into that domain. But there is a connectivity. Now let me come to the point that when we are talking about this ordered state, solid and ordered state, if we talk about semi-ordered or short range order, if we talk about no order at all, then we have three different classes of objects: solid, liquid, gas. Here in mechanical engineering, in applied mechanics lab, we are not going to deal nothing about the fluid, nothing about liquid, nothing about gas. We are going to deal with solid objects. And these solid objects, they can also be classified basically into 3 to 4 different groups. You have gone through material science, so you must be knowing, but still let me repeat, and maybe it may not exactly match with what you have learned.
এই স্যারের ভিডিও দেখতে পাচ্ছিস?
না
কি হলো?
না পজ হয়ে গেছে।
सत्यम सर को कॉल कर। सत्तू
1 मिनट आ रहा 1 मिनट आ रहा।
এই আমাদের এই ক্লাসটা রেকর্ড হচ্ছে? ওকে।
हाँ सर, मतलब वाईफाई का कुछ प्रॉब्लम हो गया, थोड़े में आ रहा है सर। नहीं तो हाँ बोल सकते हो तुम लोग, इग्नोर।
আচ্ছা, এই ক্লাসটা 2 আওয়ার্স এ ছিল না? 12 to 2
12 কোথায় ছিল রে?
রুটিনে
पास जा रहा है।
দাঁড়া ভুলে গেছি, দেখে নিচ্ছি।
3 घंटे का।
3 আওয়ার্স এর ছিল।
हाँ
ওরা মাঝে একটা পার্টিশন মতো করা ছিল।
सारे कैसे बोलो?
एक पार्टीशन ऐसा था कि धर रुक देखने दे पहले, मैं भूल
अरे
गई।
नहीं, सोहेल को ना गलत लिखा था ग्रुप में, ऑफिशियल ग्रुप में, कि वो क्या किया था, वो लिख दिया था 11 AM to 12 PM, 1 ही घंटा का लिख दिया था, तो वो गलत चीज है, ठीक है।
हाँ वो तो नहीं है, वो तो पता है। एक बार रुक जा, पहले मैं देख लेती हूँ फिर बोलती हूँ।
अरे हाँ, वो ठीक बोल रही है। 2 से 3 एडवांस इंजीनियरिंग का लैब है एंड ये वाला क्लास 11 to 2 ही है।
सर आ चुके हैं?
Yes, I'm back. Can you hear me?
यस सर।
यस सर।
Okay. Okay. একটু শুনতে পাচ্ছিস? Time and again it's going off. I do not know. Once again I'm back. Okay. Okay, can you hear me now?
Yes.
यस सर।
यस सर।
Okay. So there are different type of materials like those 4 different categories: metals and alloys, ceramics, polymers, and composites. Here in the laboratory, we will mainly do experiments on metals and alloys, but that doesn't mean that the type of experiments which we are going to do is not applicable for other materials. Okay, for say, just a minute, I'm switching off the my voice is on. I'm switching off this. Probably some connection related issues are there. Anyway, we will show you that it is true for other materials as well. Other materials means it can be for the composites, it can be for the other type of, say, ceramic and other materials. It is true. Now, what are the properties which we are going to deal with, and how these properties are related to our learning of mechanical engineering as a whole? Okay, that is very important. Yes, we will deal with mainly strength of a material. We will deal with other type of material, other type of property, like, say, we will deal with hardness of a material, we will deal with toughness of a material, and also we will deal with buckling and other things as well. Yes, in your second year class, everything is not there. Maybe applied mechanics laboratory, it will be divided into 2 groups. One applied mechanics laboratory will be in the second year, another applied mechanics laboratory will be in the third year, so far I remember. Okay, So that is the issue. That's a basic process, the curriculum we are following. The thing is, if we focus on those basic mechanical properties, there are certain things which we should take into account. What are those things? First is definitely we should take care of one thing, that is the definitions of the fundamental properties, the ideas of the fundamental properties, and second, what are the relationship between the structures and the properties of different type of materials. Suppose, for example, if I talk about, say, strength of a material, what is the interconnectivity between the strength of a material and the structure of the material? Similarly for toughness, similarly for hardness. Now the question is, as a mechanical engineer, where actually this thing will be of some use to us at all? Where? That is a question. If I talk about strength of a material, I think already the design classes have not started, or even if it started, maybe the design one. In case of designing, maybe a pressure vessel, you have gone through the strength of material coursework, so you know what is meant by a thin pressure vessel. You know the circumferential stress, longitudinal stress, etc., etc. You know, if you want to design anything, then you must ensure yes.
Sir, actually, there is a misunderstanding. Actually, sir, fluid mechanics lab class was of 3 hours, and applied mechanics class is of 2 hours.
Okay, fine, no problem.
Yes, sir. And also, sir, it's from 12 p.m., not from 11 a.m.
Today?
Every day, sir. Actually, sir, the schedule, I misunderstood the schedule. That's why it happened.
So can I continue like that now?
Yeah, you can continue, but sorry from my side.
No problem. So now the thing is, if we focus on, suppose, a pressure vessel. As a mechanical engineer, we are supposed to design a pressure vessel. Definitely. You have gone through the circumferential stress, longitudinal stress, yes. But that circumferential stress, that is bigger than the longitudinal stress. Yes, double the longitudinal stress. Very good. But if, as a mechanical engineer, you design a pressure vessel, you must ensure the type of material by which the pressure vessel will be made must be capable to withstand that circumferential stress. What does it mean, capable to withstand? It means that the material by which that pressure vessel is to be constructed, that material should not deform and it should not break. Neither it should deform nor it should break. If it deforms, the pressure vessel is deforming. No, we do not want this. If the pressure vessel is fracturing, it's breaking into pieces. No, we do not want it. So, from mechanical engineering point of view, from design point of view, we must know at which particular stress a material can deform, at which particular stress a material can break or fracture. In this particular laboratory, we are supposed to practically test some of the materials, some of the engineering metals and alloys, at which stress they usually break, at which stress they usually deform. Yes. Are we going to deal something with a pressure vessel? No, not at all. Not at all. Somebody can come up and say, sir, it may not be a pressure vessel. It can be a axle of a wheel. No problem. Axle of a car. No problem. That is also a mechanical engineering component. It can be a crankshaft. It can be this. It can be a piston ring. It can be a piston itself. Anything can be there. Anything can be there. No, it is not possible to test everything in the laboratory and say that this much is the stress it can withstand. No. Rather, we will focus on the property of the material itself. We are checking what is the behavior of mild steel. But if you are making n number of components, n number of different type of mechanical engineering components with mild steel, yes, you will have to depend on this. So basically, you are developing a foundation, knowledge foundation. And that particular knowledge foundation will help you to move ahead while designing. There are a lot of issues. There are endless issues connected with design, endless issues. And you can always have the liberty to ask me, sir, in case of a pressure vessel, this is basically a biaxial or triaxial type of situation. In case of thin pressure vessel, it is biaxial loading. In case of thick pressure vessel, it is triaxial loading. In our laboratory, when we are going to learn something about the property of that particular material, are we going to do biaxial testing? Are we going to do triaxial testing? My answer is no. Then you may laugh at, okay, sir, then what is the big deal here? What we are learning? Because in real life, it is basically a pressure vessel facing two-dimensional, biaxial, or three-dimensional triaxial type of loading. And in our laboratory, you are showing us, yes, I'm telling you, we will show you that it is basically uniaxial tensile type of loading. And I'm checking at which stress it is breaking, at which stress it is deforming. So there is a big difference. But this big difference, even if there is a big difference, then also this particular data is of much importance. There you will find no laboratory in the world as such, generally speaking. There may be some special cases. As such, no laboratory in the world who are going for design after doing biaxial testing, after doing triaxial testing. We are constructing the Howrah Bridge using a particular type of grade of steel. Very good. That particular grade of steel, if we check properly, that is not at all a uniaxial loading acting on the Howrah Bridge. But we are depending a lot on the uniaxial data from a laboratory like us. So in our laboratory, we will go for uniaxial testing. What is meant by uniaxial? What is meant by biaxial? We'll discuss. But we will make some simple test. This much I can say. We'll make some simple test, make some simple calculation, make some simple conclusions, simple results. But depending on those results, we must know the art of designing depending on those results. Yes, here comes the question of factor of safety. Here comes the question of different type of design factors, different type of other design considerations, different protocols, different type of protocols, design principles. Everything is there. But they all depend on simple findings, simple results. Simple result means results arising out of simple methods, simple testing methods. Here in the laboratory, we are going to deal with that type of simple methods. Let me give an example. First, I was just talking about the pressure vessel. Yes, in the laboratory, we will try to find out what is the yield strength of steel. Yes, uniaxial yield strength of steel. Simple technique, we can find it out. But we can find out accurately, no doubt. Depending on that data, in future, you will have to design a pressure vessel, I'm telling you. We will try to find out a particular fracture stress of a material. Depending on that, you will have to find out in future what is the fracture probability of another component. So here we are doing simple tests on simple geometries. In complex geometries, you are applying them. Yes, for that, you must need how to convert this result, or what is the art of relying on this simple data to go for a complex data, not complex, sort of a realistic data for a pressure vessel, for a bridge, for a crankshaft, for an axle, etc., etc. When you will be designing an axle, you will not be able to design without the fundamental considerations of the results which you are getting from here, from this laboratory. It's not that this data is not needed, that's something else. No. These are the fundamental data. It's not that depending on this fundamental data, there will be a next stage of testing laboratory where from you will learn the realistic testing. No, it's not like the subject of mechanics. Depending on mechanics, you are going to the next stage. Depending on strength of material, you are going to the next stage. No, it's not like that. It's like you are getting the exposure to the basic worldwide accepted techniques of measuring mechanical properties, worldwide accepted techniques of mechanical measurement, this sort of measurement, property measurement. Mechanical measurement means something else. This sort of property measurement we can do here, and that fundamental technique is followed across the globe. Across the globe, yes. There will be some more things to learn, some ASTM standards, some DIN standards, some IS standards, etc. will be there. We can touch upon those things. But here we are focusing on fundamental things, simple things, but robust or all over world accepted things. These are the techniques which we follow. So here, our objective is to get exposed to learn the fundamental principles or the basic principles of mechanical testing, testing of mechanical properties. Yes, what type of properties I have talked about? That's mechanical. It can be strength, it can be hardness, it can be toughness, it can be this, it can be that, it can be the what is the stress at which a buckling will take place. What is the stress at which a material will fracture? What is the stress at which at high temperature the material will crumble, grip strength, etc. will be there. And depending on those fundamental concepts, in future, we will design. While designing a particular object, it's not that a simple data will be good enough. No. I can supply you a data. Mechanical strength of MS mile steel is this much. If you do not know how that particular result has been arrived at, how I have got that particular result, what is the method which I have followed to get that particular result, if you do not know that, you will not be able to design anything. You can believe me. You can trust me. Without knowing the fundamental principle, you cannot use the suitable design criteria, suitable design formula. You cannot select the suitable design protocol, standards. You cannot select if you do not know the fundamental principle, fundamental way by which the result has been arrived at. How I am getting the yield stress of a material, you must get a clear-cut idea. Yes, this is the methodology by which in the laboratory we find out the yield stress. Then only you can use a factor of safety or this or that, etc. while designing a realistic component. So this is a fundamental thing. Strength of material, yes, it is one thing. Mechanics, that is one thing. But this particular laboratory, yes, whenever I teach any particular subject, I try to put myself as a brand ambassador of that particular subject. I try to advertise a lot. It's sort of an advertisement. But believe me, this is not exactly an advertisement. In the true sense of the term, if we do not know how the testing is done, it is very difficult to use the design principles. Okay, that's why we should have enough of exposure. Yes, the laboratory we have, it's not up to the mark. We have some good quality instruments, some bad quality instruments. Some of the instruments are pretty old, but anyway, even if it is pretty old, it can give us good result. At least it can show you what are the deficiencies, what are the drawbacks and limitations. It can show you. So these are the things. Let me go to the discussion, which I think should be done at the first class. Whatever I have said is basically some additional thing which I think as a mechanical engineer you should learn. You know about cutting tool. Have you seen a cutting tool? Anyone having seen a cutting tool in the Blue Earth workshop? Have you seen it?
No, sir.
Turning operation? No, you haven't seen. Anyway, if you go to the Blue Earth workshop, you haven't got a chance. Sorry, you haven't got any chance to go to the workshop. That's why the problems are there. But if you go to the Blue Earth workshop, or if you go to any roadside shop, just roadside shop where people use lathe or something like that, you will see that a lot of operations are being done. Turning operation, honing operation, cutting operation, these, that, whatever it is. If I think about a turning operation, we use a cutting tool. The cutting tool is basically cutting something, cutting a metal. So the cutting tool must have a proper hardness. Otherwise, it will not be able to cut anything. So the hardness must be high. But the thing is, if you see any roadside shop, if you see our Blue Earth shop, you will find while cutting, we are giving some oil at the cutting junction, at the cutting point, or sometimes even some water at the cutting junction. Why? Because with time, because of continuous rubbing, continuous cutting, continuous contact under high stress, there is heating. We want to cool it down. Why I am talking about this? Because there is a term known as hardness, there is a term known as hot hardness. Hot hardness. At higher temperature, the hardness goes down. So these sort of concepts are important as a mechanical engineer, because if you are joining a company like Sandvik Asia, or say what type of company I will say, Vidya, Sandvik, or this sort of companies. So these sort of companies, they develop cutting tool, different type of cutting tool. It can be high carbon steel, it can be silicon nitride, it can be silicon carbide, etc., etc. Different type of cutting tools or cutting tool inserts they develop. They have specific geometry, etc., etc. In the third year, probably you will learn that tool geometry. The thing is, we must know as a mechanical engineer, while I am designing a cutting tool, I must know what is the importance of hardness. In case of pressure vessel, maybe hardness is not that important. In case of pressure vessel, strength is important. In case of this thing, hardness is important. Similarly, if I go for some other component like an axle, or it may not be an axle, maybe a piston ring where the piston is coming, or maybe the casing, maybe the crankshaft. There are a lot of components where axle fracture is very common. Axle fracture, breakage of axle breakdown, it's very common. If you go through the Delhi road or maybe the GT road or something like that, high-end roads where a lot of trucks move, you will find every now and then you are coming across different motor cars or maybe the heavy duty vehicles. They are standing on one side and they are suffering from that axle breakage. This sort of thing happens. Now, if it is a question of breakage, if it is a question of fracture, I'm not talking about a breech fracture. Yes, breech fractures also happen. If you're interested, you can write in the Google or some search engine what are the different famous, you can say notorious sort of famous, there's breech failures. You can see. And the breech, they can also fracture, they can also crack, they can also break. Similarly, we can think about axle breakage, axle fracture. Yes, the property which is important for this particular issues is toughness. So there can be some cases where toughness is related. There can be some cases where hardness is related. There can be some cases where strength is related. Why I am focusing on these three? I personally, this is totally my personal idea, these three fundamental properties, strength, hardness, and toughness. If we know these three properties in details, and if we know the material science backup of these three properties, how strength is governed by material science or structure of a material, how hardness is governed by structure of a material, how toughness is governed by the structure or the microstructure or whatever you call of a material, that thing gives us enormous confidence to understand this whole domain of mechanical testing. So if the take-home message is concerned, if we think about the take-home message from this laboratory, maybe for next few months, couple of months or maybe 3 months or so, the take-home message is simple. For me, you must be exposed to different type of techniques of testing. That's fine. Okay, some of the things will be remembered by you. Some of the things will definitely you will forget. But the fundamental three things, strength, hardness, and toughness, what do they mean? And how they are related to the material science behavior or material science entities like defects, different type of defects, like different type of microstructural entities, how that they are different related to grains, this sort of issues. If that thing is more or less clear to you, I think that's more than enough. That's more than enough. I should say much more than enough. This particular thing we should try to focus on. So maybe as because we have time and as because we are confined to our own space, own place, probably will not be able to discuss much about the experimental things. Yes, we will focus a bit on the material and property connectivity. That can be handy for us, and that can give us an edge while designing, an advantage while designing. Along with that, I will share some videos with you. Towards the end, let me just tell you three definitions. I will elaborate one by one in the next few classes. I'll select which one we should go first. I'll have to check the syllabus as well. What is there for you in the first semester and first applied mechanics laboratory. I'll have to check. Probably I know, but still I will have to check. Let me discuss this. Let me define strength. You have gone through a coursework of strength of material, and how can I teach you strength? You know what is strength. I am defining it in a different way, maybe in a different way. It may not exactly match with your own conception. If we try to cause an overall deformation or bulk deformation, overall deformation means, suppose I have a pen in my hand, I'm trying to pull it apart. I'm trying to increase its length. It's not that its length, if I apply sufficient amount of force, its length will change in a small area close to the point of application of my load. No, throughout the body, its length will change. If I want to reduce its length, if I compress it from both sides, then its length will change. Its length will get reduced all over the body. All over the body if I am applying sufficient amount of force. So this sort of deformation, be it elongation, be it compression, be it reduction in length, this is basically known as overall deformation. The mechanical property by virtue of which a material resists overall deformation is known as its strength. The property by virtue of which a material resists overall deformation is known as its strength. Is it given by sigma y or yield point? Is it given by UTS, ultimate tensile stress? We will discuss those things. But for the time being, this is basically the resistance to overall deformation or bulk deformation. Strength is the resistance to that. Okay, let us focus on the next one. What is that? Hardness. I'm leaving someone in the class. Suppose, hypothetically, just imagine, I'm leaving some of you in the class alone, and I'm giving you a very hard pin, and all these wooden planks, benches are there. So you will definitely write few things on the benches, and if I am kept like that, I will also write. But if I do not give you a metallic pin, sharp metallic pin, you will not be able to write anything or put a mark on the wooden plank. If the opposite is done, if I am leaving you alone in the class and all these wooden benches are replaced with metallic benches, and I am giving you a very sharp wooden pin, no, you will not be able to do anything on the metallic benches. You will not be able to do anything. The thing is, it is basically the resistance to scratching which determines hardness. It can be resistance to scratching. It can be resistance to cutting. If I have a very hard material, how can I cut it? If I have a harder cutter, then I can cut it. So hardness governs whether a material can be cut or not, whether a material can be abraded or not, whether a material can be scratched or not. So we can define hardness in a simplest way. It's resistance to scratching. It's resistance to this sort of abrasion, like a jack plane removing some material from wood. If the jack plane is made of also of wood, then it will not be able to remove the material. If it is made of steel, if it is made of some hard material, then only it can remove the material. So it's resistance to abrasion, resistance to cutting, resistance to scratching. So we can define hardness in those sort of simple manners. What about toughness? It is basically resistance to fracture. Resistance to fracture, the property by virtue of which a material resists fracture. That is toughness. I am giving you one example. Suppose I'm giving you two particular components. One component is of a porcelain cup and another component is of an aluminium glass. Porcelain cup and aluminium glass. Okay. Hypothetically, just imagine both of these two components, they have the same mass, and I am throwing them to the nearest wall with same velocity. So half mv square is same. So I am imparting the same energy to both of them, but the fate will be different. If I take 100 such porcelain cups and throw them to the nearest wall, in 100 cases, maybe in 99 cases, I'll find the porcelain cup is breaking into pieces. Maybe in one case, no, it's not breaking. It may be. But generally speaking, it will break. In case of aluminium, out of 100 cases, 99 cases, it will deform. In one case, it may not deform. It may be. But the basic thing in case of aluminium is deformation. The basic thing which will happen in case of porcelain cup will be fracture. Now, one of these two material, that means porcelain, is not able to resist fracture, but aluminium is able to resist fracture. So the material aluminium is tougher, more tough than the material porcelain. So what is toughness? It's resistance to fracture. Resistance to fracture. Now, why all these things happen? Why one particular material is tougher than the other? Why one particular material is stronger than the other? Why particular material is harder than the other? These sort of issues will also come into picture. Yes, we may skip. Definitely we may skip. As far as the objective of this particular course is concerned, it doesn't come. All these things doesn't come. That material and the property correlation. But I think as a mechanical engineer, we should know all these things. And as because already you have finished a coursework of strength of material and also a coursework of material science, definitely you should try to correlate, and that gives enormous satisfaction. Enormous satisfaction. If we can really correlate that, general plane, in a general plane, not in each and every case, general plane, if we can correlate, then it gives us satisfaction, it gives us confidence, it gives us some boost up before designing something. Okay, we will try to do those things. This is the first introductory class. This much I think is good enough. From the next class, what we will do, we will take up experiments. We will discuss about experiments. And while discussing, suppose in the next class, I am going for an experiment on toughness. Say, for toughness, yes. On toughness, no, this is not the only thing I can discuss about toughness. I should discuss about toughness. We should discuss a lot of things about toughness. And then only we should go for the experiment on toughness. So in the next class, maybe we'll go for, I'll have to check the syllabus. If it is toughness, if toughness is there, maybe I'll go for toughness first. We'll go for strength second. We can go for something else. But in that way, in each and every class, we will focus on a particular testing principle, testing, experiment, to focus on an experiment, and related to that experiment, we will discuss the theoretical issues. And in these theoretical issues, I will try to correlate as a special endeavor, sort of, you can say. But rather, I feel that this is a natural endeavor. It should be naturally done. It demands that this should be done. The correlation between the property and the structure. That also I will try to correlate. So in the next class, we will start doing experiment. I do not know how to do the experiment. If I can share with you the experimental videos. Shottam, you can try to get it from other sources as well, from other sections. I know in some sections, probably teachers, they have those things ready at their hand. If they have already supplied, or within a week or so they supply, you just take it. Otherwise, you will have to come to the university. I do not know whether this week I will go to the university or not, because up to 14th it was closed. Our department was closed. So this week probably I will go. Maybe tomorrow I will go, or day after tomorrow definitely I will go. Somebody will have to come to the university with a pen drive so that I can give those videos. But I think there is no point in coming to the university for this purpose only. If you can get it from someone from other sections, get it. We will focus on the experiments, but we will focus on the theoretical parts as well. Seeing the videos, yes, I also demonstrated one or two videos. I do not know that is there in your syllabus or not, but there are other videos. Other teachers, they have demonstrated the experiments. That's fine. Go through those things if you can collect in between. And I will focus one by one on different mechanical properties, configurational properties, and we'll discuss in the class. The videos, if you can collect it, or give me some time so that I can collect and give it to you. But it is very difficult to transmit in the sense to send it through email or something like that. It's better to collect it through the pen drive. So that can be one way. Shottam or somebody else can try to do it from me. And the other thing, we will focus in the class. What I will do in the WhatsApp, Shottam, you have already created the WhatsApp group, huh?
Yes, sir.
Yeah, in the WhatsApp group, I will keep on giving few questions. No, you are not supposed to answer those questions and send it back to me. No, not at all. These questions I will be giving just because preparing the answers of the questions will help you a lot. I will give you the name of 2 books also in the group. I would like you to go through the books as well. Don't think that okay, fine, this is a lab class. I can come to the lab class. I can switch on the. I can. Be present in the class and finally attend the evaluation. That's all. You definitely can think about that. But I personally feel as a mechanical engineer, a budding mechanical engineer, we should try to give a little bit more. In that sense, if you go through the books, that will give you some sort of exposure, and if you can prepare some answers from yourself for yourself, then that can be handy in the future years. Not even in during your stay here, even beyond the stay, some important issues can be there, which will be noted down while answering these questions. So I'll share the questions, I'll share the name of the books, and remaining things, whatever discussion we have, we can go for the group should be an active one. Okay, it should be an active group where we should interact. And if you have any query, you should have any doubt, any doubt, it may not be exactly related to that particular topic. It may be related broadly to the overall topic of this particular coursework. That also we can discuss. Okay, so that's all for me. If you have any query, you can ask. Is there any query from Shidshudeb? I can see Shidshudeb.
হ্যাঁ স্যার বলুন, ভালো লাগছে স্যার অনেকদিন পর আপনাকে দেখে।
দেখতে পাওয়া
হ্যাঁ স্যার,
যাচ্ছে, শুনতে পাওয়া যাচ্ছে।
সেমিস্টার 1 এর পরে সেই মানে এতদিন পর আবার
Anyway, if you have any query, তো এখানে একটু গ্রুপটার মধ্যে ইন্টারঅ্যাক্ট করো, that will be good for me as well. We can interact in the group. ঠিক আছে, আজ ইন্ট্রোডাক্টরি পার্টে এইটুকুই থাক। From the next day, from 12, Shottam has corrected, that's fine. From 12 we'll start from the next week. ঠিক আছে, okay, thank you.
Okay, sir.